Okay, hi everyone. This video is going to focus on condensed electron configuration, which is a faster and easier way to go ahead and describe where the electrons are in an atom. So even though standard electron configuration is faster than drawing the orbital diagrams with all those boxes and all those arrows, it can still be a pain. I'm not going to deny that fact. So for example, Tennessee's standard electron configuration is ginormous, as you can see. So once you get used to the pattern, it becomes faster, but that's still a lot of information to write out. So chemists being the eternal lazy people, we're always looking for a faster and easier way to do this. So we came up with condensed electron configuration. Okay, so condensed electron configuration is an abbreviated way to write the electron configuration for an element. And it's sometimes called the noble gas configuration because the closest noble gas is going to take the place of writing out all the core electrons. So for example, Tennessee's condensed electron configuration gets shortened down to radon 7s2, 5f14, 6d10, 7p5. So much faster and easier than writing out everything the longhand way. So let's go ahead and actually figure out how to do this. So same first step, we want to figure out the total number of electrons. Remember, we can check our work by adding up the superscripts plus the number of electrons from the noble gas that we're using. So we want to find the closest noble gas with fewer electrons. This is key. It always has to have fewer electrons. The way you can check that, the atomic number of the noble gas should be smaller than the atomic number of the element that you're using. You're then going to write the symbol for the noble gas in square brackets. And then starting with the row that your element is in, you're going to continue writing the electron configuration as you normally would. So a hint for this, remember the period number always tells you which s orbital you're filling first. So it's always going to be some s orbital that comes right after the square brackets. And then, like I said, you want to go ahead and check your work once you're finished. Make sure the total number of electrons is equal to the sum of your superscripts and the number of electrons in your noble gas. Okay, so one caveat. When you're using condensed electron configuration for noble gases, you still have to use the closest noble gas with fewer electrons. So for example, if I'm doing krypton, I'm not allowed to just write krypton in square brackets and call it a day. I have to go to the closest noble gas with fewer electrons, which is argon. So krypton's condensed electron configuration is argon 4s2, 3d10, 4p6. Okay, so I have four elements. I want you to go ahead and try on your own. Write out what their condensed electron configuration would be. Go ahead and pause this video and then come back and check your answers. So go ahead and pause this now. And let's go ahead and check the answers. So cesium is xenon 6s1 because it's in period 6. Cerium is xenon 6s2, 4f2. Remember, we subtract 2 from the F block. Bromine is argon 4s2, 3d10, 4p5. And then francium, even though it's super huge, is just radon 7s1. So I hope this helps and answers your questions about condensed electron configuration. If there's anything you need help with, please let me know, and I'll be talking to you guys later. Bye.